If fire needs oxygen, where does the sun get oxygen if there's no oxygen in space? So hello guys and welcome to a new episode of Videopedia. This is your host Tilak. Indeed, this was a scientific problem for hundreds of years. If sun consisted of oxygen, it would run out of fuel in a few hundred years. So what's the deal? But wait, nowadays we know more. What other objects glow like the sun, even without oxygen? This example of a lamp bulb shows that not all objects that shed light need oxygen to do so. Of course, for light bulb that gas is typically some inert gas, which gas is typically used in light bulb. In fact, the light bulb doesn't use up the gas. Instead, it uses an electric wire, i.e. a resistor, heated up by the electricity flowing through it. The wire heats up, in turn heating up the gas. The sun is a bit similar to a light bulb. From early spectroscopic studies in the 1800s, we know that it consists of gas, mostly hydrogen, and helium. The latter was actually first discovered on Sun, giving the element its name from Helios, Greek name for Sunday. Nowadays we also know that this gas is heated up not by directly burning its chemical constituents, but by a special phenomenon that is the reverse of what's happening in nuclear power plants, nuclear fusion. While in nuclear power plants uranium splits up and by doing so releases energy, nuclear fission, in nuclear fusion the hydrogen atoms combine to form helium or even more massive particles. In case of light particles like hydrogen, this again releases large amounts of energy. The energy released speeds up the particles in the sun's core, and in turn these superheated particles slowly bounce around and raise to sun's surface. There, the temperature of the hydrogen-helium gas is 5,500 degrees Celsius or near 10,000 degrees Fahrenheit. A gas this hot will glow literally like the sun, finally releasing the heated energy to the universe and, consequentially, to us. Sun continually loses a tiny portion of its mass to keep shining, combining hydrogen to helium in its fusion forge, its core. From observing other stars like it, we know it has enough nuclear fuel to shine for another few billions of years. So for now, this is Tilak signing off in this video. Thanks.